हेलो हेलो, माइक टेस्टिंग, हेलो हेलो, सुनाई दे रहा है? नहीं आ रहा है? हेलो हेलो, लूज है? नहीं चल रहा है, तो वो तो चल रहा है, उधर तो प्रोजेक्टर चल रहा था। लूज है? तो चल रहा था अभी। लूज है, क्या हो रहा है? इतना बड़ा तार कितना छोटा है ना। हम्म? आ रहा है साउंड अभी?
lines. Whereas like classic PhD, classic students, even if it rings a bell, not follow me from nothing. There are very few students who ever answer a question that we have studied testing. Right, how many of you have done basic programming in Python? Please raise your hand. All of you. Good. That makes my life easy. I can just rush through and go anything. How many of you have used the SciPy package? Only the master students. NumPy? Most of you. Pandas? Some of you. Good. So, as usual, there is a Gaussian distribution of what has been done. Okay? Don't worry about the river, just go through the basics of things and then very quickly go through this. My machine is taking time to start Anaconda. So I'll be following Vinesh Helpshis. This is the O'Reilly Python for Finance, and then we go on to the same author's AI for Finance book, so that in case if you don't follow me, you will have time to go back and follow the things as well. I like the book because it doesn't spend too much time digging into optimization mathematics or numerical algorithms. It jumps straight into coding. And considering a number of you have got different stages of studies, we will jump straight into coding without worrying how the mathematics part of it works. Right, so as all of you have done Python, all of you should know the different data types available in Python. We're going to deal with data, right? So maybe, so you have come across these different. So 4 bits in binary, what will that be when they convert it to decimal? With 2 to the power 4, right? So you can go till 0 to 15. If I'm using an integer number, 8 bits will they go up to?
2 to the power 8.
Which is? 2 to the power 8 is?
The GIAN has to be.
पूरा टेबल पढ़ना होगा। So in case the 2 powers, the beauty of computer science is that we do configuration, but our own configuration is very limited to 2 to the power number. Remember 2 to the power almost till 12. Doesn't come quite really. So we have now got a problem. You said it's 8 bit. It only goes to 256. Even if I define the 8 bits as your characteristic and mantis, I can't go very high numbers. It's certainly not 8 or 4. So how do you think again? It could have been 8 bits if you were slightly older when we had 8-bit machines. How many bit machines are most of your computers? 64 bit. Down. So floating point number follows a 64 bit. They follow the IEEE 754 standard. But this gives you 15-bit accuracy or 15-digit accuracy in your numbers. So quite often we have to deal with numbers. Is that again? Can you hear me now? Well, you guys can always hear me, hopefully. So if you need better or different, I'm going to just recommend some packages. It's not always the best package, but there will be other, but this might be a good package to start with. So a decent package is decimal package. So have all of you got your Anaconda running? Let me see if mine has started. Oh, mine doesn't like starting today. was not starting because my computer was stuck in network login. So if you can start your Qt console on your Anaconda, and let's play with. If you're having difficulty, shout at me. I would like you to be running rather than me talking. Okay? And let's explore the pluses and minuses of the decimal package. So it allows us to do arbitrary precision object for floating point numbers. And what would be arbitrary? So actually, you know what? Let me give you a code. So if you can look at a number, so what I'm trying to do here is I'm trying to say divide 22 by 7, because that's a number which we often see in our school days. What's 22 by 7? Is it pi? Is it pi or is it an approximation to pi? So how do you remember pi? Till how many decimal digits do you know how to remember pi? 3.1, 4, 5, 6. 4 digits? Has no one told you that mnemonic, may I have a larger cup of coffee after attending a complex lecture on quantum mechanics? Okay. My son is remembering this right now. He's 10-year-old. So he thinks the more number of pi I can remember. So may I have a larger cup of coffee? Is it good? Mnemonics to remember.
Yes,
Yes.
alphabet.
So may is 3, pi is 1, have is 4, and so on and so forth. Okay? So not going into pi because Python has a good way to remember pi plus different decimal locations. Let's try to deal with this as decimal package in C. If you can, so what I've done here is I have created a new number D. So the decimal.get context tells you how many bits is being used currently, what kind of object it is, and then I've done division of this by 22 by 7 to see what's the number which comes here. And then the next line I have changed the number of precision here to 10-bit precision, and then I've got 50-bit precision. I've done the same maths again. So let's see if you can do it to a different precision and be able to work. So all you should be, if you have got your Qt console running, all you should do is import decimal and you should be fine after that. So at some point I will leave my chair and come to your machines to check if it's working. If not, do give me a shout. So we will just do decimal get context. What's the line does your Python give it to you? Is machine a Python idea?
Sir?
Is machine a Python idea? Let's check.
You can just check once. Pi version CMD. Anaconda तो नहीं होगा. But Python might be installed. I'm not sure.
I don't think there is much here.
Jupyter. Can check with Jupyter. No. So we can use the Colab, I guess. Google Colab.
Online जाना पड़ेगा ना.
जी sir.
Okay, let's see if these guys can run it. So can you somebody give me the reply of their decimal.get context? The first line. I'll walk and see if you have got your get context run. Hang on. Right, so let's give it a time till you guys get things installed. Somebody should be running it on your, अगर आप spider run कर रहे हैं तो spider पर भी आपको मिलना चाहिए. So can you give me the output of what does get context tell you? Good, good, good. So let's just limit to the precision. So how many bit precision it is giving us? 20. Actually, it's not 28 bit. It's giving you 28 decimal places. Right? And now change the precision. So do we only have one machine there with both the girls? Not giving him both the girls, right? I don't understand that. Achha. Should I shift you somewhere else? You're okay to? Okay, fair enough. So now let's see if we can change the precision to 4. I've done it for 10. See if you can do it for 4. And then can somebody tell me what's the rounding of error when we do it 4-bit versus 28? 4 decimal places versus 28 decimal places. Guys, the quicker the reply you give to me, the quicker we'll proceed. Sorry? Good. But we are able to change the precision, right? So if you are following me, so here I have created 3 numbers, D, E and F. And you can see the rounding off here goes from 2857 to 3. What would be interesting to see, just stop the rounding before 8 and see where it rounds up to. 9 or does it round up to 8? So do till 4 decimal places. Did you at least ask his permission to join him? Yeah, fair. He asked them if they want you or not. Or you did the major sin. At least he removed the bag of a gentleman. You removed the bag of a lady. That's never to be touched. हाँ बिना पूछे आप उनका बैग एक जगह से दूसरी जगह, वर्ल्ड वॉर शुरू होते हैं भाई लेडीज बैग पर, संभल कर रहने को. Good. So hopefully all of you, is anyone still not getting the decimal package running? Decimal 1? You're getting an error in division dividing 2 numbers. What's the error? भैया बुढ़े हो गए हम लोग. Okay, which version is your thing? What your object is not callable? Is everyone having the same error? Is it not imported? But this is the problem when it happens when you have many machines, because I don't know what libraries are already there on your systems. What you guys, any luck? They're getting in. Yeah, that's what we should get. They are getting a module object is not imported error. No, you are getting right? Or were you also getting this error? No, that's what I expect to see. What are you? You are using an Colab, right? Should we shift everyone to Colab? Okay, guys, they can make it work on Colab. Should we shift to Colab? Because I'm not going to debug everyone's machine. That will be real pain. Let's go to Colab and see if you can make it work there. If not, stick with me. We're not going to play much with decimal package. It was just an advisory on what can be done if you want to change the precision. Okay. So we had these different type of data types there. The important data type for financial analysis is the string data type, because a lot of our data is often in forms of some form of text. Reduce its volume. Better. Yes. Now, to all those who have already done their Python basics, what's the difference between tuple and list? Oh, the technical classic answer, immutable versus, what does that mean? Good. And what's dict? Okay. Good. So I don't need to go through it. Everyone is clear with these things? Okay. Now, in strings, particularly when handling large CSV files, and those who are having strange data formats, one advisory which I give to my student is to use the regular expressions package, and that works very nicely. Okay. Good. Now these are going to be your real good friends, the list and dictor, because we're going to deal with large number of data series. So we can put everything as an array. How many of you have already done data structures? One or two, okay. So you know how a dictionary will work and what kind of data type it is that. Good. Now, essentially in time series analysis or a lot of financial analysis, we are dealing with arrays of numbers. The first order thing would be to use something like list to create these arrays. Unfortunately, list was not designed for creating arrays. It's much broader than that. It can do many other things than just pure simple arrays. And hence it limits its usability, or its not usability but ease to use. The other option is you can use the array class, but an even cooler class will be numpy.nd array. Okay, but it gives us a lot of built-in methods, and particularly when you are going to do multi-dimensional arrays, it becomes quite handy to use it. So let's try. So latecomers, we have started. They're showing me a phone for. But I meant to say that we have started working on computers. So if you have got a computer, start running it. If not, join one of the people with a machine. Okay? So what I would like to do now is to see what happens when we multiply a list with a number versus an ND array with a number. Okay? So hopefully you can run something very simple like import numpy as something, create an array, whatever numbers you put an array there, and then also create a list of same type of numbers and multiply them with 2, or multiply or do a square. So 47, 48, that should do. And then just do line number 55, 2 times a. Can also create another list. Let's call it M or L and do 2 times that, and let's see what's the difference. And can somebody tell me the difference once you have got it running? So this is you're talking about ND arrays, right? A is an ND array. What I'm asking you is now create a simple list with the same numbers and do 2 times that. Get copied again. And that's the first difference we'll see between a list and an ND array structure. So one person has got it. Has anyone else got it? Is the question clear? Those who are still struggling, raise your hand and I'll come to you and fix your. Let's do a walk around. क्या हो रहा है आपकी मशीन में? चल रहा है, गुड. और आप लोग क्या कर रहे हैं? So one of the reasons I like my Qt console is it has got a white background. I have become tired of dealing with a black background. You know, as you get older, आपकी आंखें खराब होने लगती हैं. खासकर people like us who have spent our life looking at a screen. So can somebody else tell me what's going on? आपके यहाँ क्या हो रहा है? So that's an ND array, right? Now create a list, normal list. आप लोगों ने कहा था कि लिस्ट के बारे में आपको पता है, तो I'm sure you guys can run it. Have you done it? Does it repeat itself in list? Good. What about you guys? NumPy not defined. Yes, so it should be np.ndarray, right? What about you? भैया, this is a health and safety hazard. किस दिन मुझे गिराओगे आप लोग यहाँ पर? We just started. Okay, fine. So create an array. Create a smaller array, right? And if nothing work, इस पर नहीं काम कर रहा होगा, then we have got something to worry about. So if everything works according to plan, 2 times a for ND array leads to scalar multiplication, as if you take a vector and you just multiply that each element of that vector with the same number. Okay? If you take a list and multiply it with 2 times, it essentially copies the list twice. Agreed? Don't worry भैया, मैं move करता रहूँगा. Happy? Let's give another minute for our newcomers to catch up. Okay, the other issue between these two is the speed. And this is vital for us. We are लोग छोटे-छोटे numbers deal कर रहे हैं, right? And most of you are using the CPU of your computer. So let's now compare the speed between list and ND arrays to how fast or slow it is. Okay? So what I would like to do is to create a list of random numbers and just add those numbers. So I think this is how you will go about creating a list of random numbers here. And the first line should tell us what's the time the CPU has taken to run it. Now it's not the most well written code. We are just basically using a for loop to create a sequence of numbers. So now we will start seeing differences between your machines. So each one of you will give me a different time. So there are 2 time equations which we are looking at. The second one is for adding all of these numbers, and the first one is just for creating it. So give me how much time it takes. Will it be beneficial if I share the slides so that you can cut and copy and paste the code? You do have tab extension in most of them, right? So you can type the first few words and that will extend. Okay, when we're in the early days, let's do it last way. That way you learn not to do mistakes, but later on we will share the code. And if it's taking too long, just create a 500 by 500 matrix rather than a 1000 by 1000 matrix. That's not one line, by the way. There are 3 lines here. Right, so I would have hoped that. So what's your CPU time for this? What mistake have I done? I'm getting a unexpected character after line content. So what's the mistake? If you get this working, we should also be looking at creating the same matrix using NumPy and taking how much time that takes. And here's the code for doing that. You got the time, okay? So what was error in my previous code? Why not? How do you find the time then? Only the backslash is a problem. Right. So now compare this time to the time for an ND array. So can you give me your time on your machine? 453 millis. 0 nanoseconds. Are you using online version of a Python? You're creating a MATLAB of 5 by 5 array, right? यार कंप्यूटर की इतनी भी मजाक मत उड़ाओ. 5 by 5 array तो कोई भी play कर लेता है. Let's do a 10,000 by 10,000 array. That's what we are doing. We're creating a large matrix and we want to see what happens when we deal with large matrix. Okay? So guys, the error here is that this backslash, I think that had come when I was copying from my Jupyter code. Right? So remove this backslash and just create this time and tell me how much CPU time it took you. 1.53 seconds. So everyone has a faster computer than I have. What's the size of the array which you are creating? 10,000. Okay. And what's the time you needed to add these numbers? Just give me first decimal place. 3.9 nanosecond. Second. So to create an array which is 10,000 by 10,000, you took 3.5 seconds, right? That seems like a decent number. I'm jealous with this girl's computer. I need to check how fast the machine is. Oh, you are running it on, oh no, you are running it locally, right? 1.53 second, right? Not nanosecond. Nanosecond was worrying me. So guys, this is interesting. To create a 1,000 by 1,000 array or 10,000, we are taking 1.5 seconds, which is slow. Okay? So very soon we'll be pushing your computers beyond its comfort zone. Let me just check if everyone else has got it running. What about you guys? Let me see. Random.cows 01. For j range of I and for ये क्या है, कौन सा वेरिएबल है यहाँ? Let's run it. What have you defined here? What about you? Got it working? Give me the time.
How many? 3 minutes. Still it's long. What about you guys? What's the time which you have got? Uh-huh. Good. What about you guys? 40 seconds. Good. And back there? What, 1.9 second or did you say picosecond? Millisecond. Millisecond. I'm impressed whenever a machine works faster than expected, right? You're creating 1,000 matrix array. I've asked you to create 10,000. That's cheating. So you see, Janta, we have got this complexity, right? मेरा machine आप लोग से fast होना चाहिए. ज़्यादा पैसे दिए थे. Good. So we are all dealing in terms of seconds, if not more, right? And compile time is even longer now. Okay? So note down these numbers. Okay? So this is the number which is used to create a 10,000 by 10,000 matrix and add all the numbers. The second one should give you the size of the matrix, which is fine. Okay? Now let's do the same operation using NumPy. And let's see is there a time difference between these two. So to give you a comparative so मेरे machine में the list process took 34 seconds, where NumPy took 3 seconds of CPU time. So NumPy takes 1 second less. Only 1 second less. I got 10 times benefit on my machine. Are you looking at addition of numbers or you're looking just at creation? And what about addition of these two numbers? .3 seconds. Is it longer? NumPy is taking longer than normal list for you. So which is taking longer, NumPy or normal list? By how many times? Times. Now that sounds more impressive. Let me go and check this girl and see how she has managed to make it just to run in 1 second. So, good. So that's 1.53 second. Now you have 141 millisecond. Right? Agreed? So you get a 10 times runtime advantage. हुआ? 10 time faster हुआ ना? 10 times faster, right? So NumPy is giving me 10 times faster computation. All of you at least 10 times, so 8 to 10 times faster आपको मिलेगा. मिला? Now nothing comes for free, does it? अगर numpy इतना फास्ट कर तो लिस्ट वाले भी अपने आप को फास्ट करते. What are we paying for this speed? Nothing. There's no free lunch in the market, is there? Good. We will see what are we paying very shortly. The next thing which I would like to tell you about, so this is just introducing to the NumPy package. There are 10,000 different things which you can do with ND arrays, and we can spend the whole day just talking about ND arrays, which we don't have time from. The other thing which we do quite often do in financial analysis or any business analysis to deal with time series data, right? We have got data at each time interval. And sometimes it's not just one sequence of data, it's multiple column data. So this is where pandas, time frame and series objects become very, very handy for us. So a data frame allows us to have a tabular data organized in columns, and series is kinda the one-dimensional approximation of data frame. So series allows us to have a one-dimensional data object with an index. Right, so there's a numeric index with there. So let's again play with this. Let's create a data frame object. So it is very much like as if you're working with an Excel data or any SQL database. I have just created a very, very small, I've taken the data again from your sales. It's a very small database, so import pandas as something and then create a two-dimensional database, okay? And then we will play with what happens with some of the simple structures which a data frame enables us. So it enables very quick searching so you can find a particular index, you can find multiple indices. So we're dealing with a small matrix because then we can learn how to do simple analysis on that before we start dealing with more complex number. Can somebody close the door, please? I will do it. So here in what I have created is a 4-row element wherein the indices are A, B, C, D and the values are 10, 20, 30 and 40. ठीक है? And then you can do simple things like list all the indexes, list all the columns, look for location of say any particular value of index and so on and so forth. ठीक है? आप सबों ने have you created a data frame object? Yes. Now this is vital because I'm going to play on this data frame. Okay, so I will wait for till everyone has got the first part. So I need to hear a yes from all of you. Should give given you a buzzer. जब आपका काम हो जाए तो press a buzzer. Students don't like talking. Classroom छोड़ के सभी जगह आवाज निकलती है, right? So I'm following giver's help sheets, but considering कि मैं ये काम रात को 1 बजे कर रहा था, there is high probability I would have done a mistake while copying things. So after giving my lecture yesterday, I went and slept at 4 p.m. in the evening, और फिर 9 बजे मेरी नींद टूटी और फिर मैं सो ही नहीं पाया. So I started checking the code again. So our next task will be something very, very simple. That will be to square the numbers and then see if we can do a better way of squaring. How much time does squaring these number takes? So we have these numbers 10, 20, 30, 40. I would like to square them. Something as simple as that. So there are two ways I could do it. I could just do a normal squaring, or I could, go with a step. We can also add those numbers. Now can you tell so give me the differences. Same. The last one, sum is just adding the numbers, right? No, I want to know the time. Result to same ही होगा. I don't think computer can do 10 square mistake, but I want to know the time it takes to do that. So to give you my operation, so just df squared immediately takes 440 microsecond on my machine, whereas if I do df dot apply, it takes me 1.35 millisecond. So time find करने के लिए क्या करेंगे? You'll put percentage time before that operator. 0 nanosecond. बड़ा फास्ट मशीन है भाई आपका. This makes me jealous. Anything which takes 0 time, you have made a perpetual motion machine, right? यहाँ छोड़ो, NVIDIA को beat करने का ये करेंगे. Good. And do standard squaring. Both is taking 0 nanosecond. Brilliant. Well done. Okay. Sorry? 4 microsecond. Okay. So it's a छोटा series, right? Four numbers को multiply कर रहे हैं. Should we make it a 10,000 sequence? नहीं, अभी नहीं करते हैं, because there's something more important for us to deal with. So all of you have squared the numbers? Good. Let's go to the next thing. Let's try to increase it now. Okay? Now, this depends. It's possible to increase a data frame in both dimensions. You can add X column, you can add Y column. Now, it depends upon अगर आपके पास पुराना manual है या फिर पुराना version है, you would be able to use df.append. अगर आपके पास नया पांडा है, then you need df.concat. Okay? But let's just use the very simple structure. Just put another column, df float, so give it another name, and just let's give some more numbers to that. Okay? So we have gone from an index and one column to a data with two columns now. Just कोई random number add कीजिए. It doesn't matter what we are adding right now because we want to deal with the procedure. Good. Okay. It seems 4-digit numbers were not very nice, but बड़ा जल्दी computer काम कर लेता था, right? So let's make it a life a bit more interesting and let's deal with a proper data series, right? So either I can import a financial data immediately, and this was one of the worries which I had yesterday. If I give you a data immediately, I have no idea how good or bad your computers are, okay? So to start with, let's deal with a random number sequence. What we will now do is we'll create a 9x4 column of random numbers. Assume they are some sort of stock prices, okay? And the beauty of dealing with random numbers is each one of you will have a different number to play with. So let's do this. Let's just create a simple data frame object with a 9x4, and you can take any random seed you want, okay? So I've started with this random seed of 100. You take any number which you want, and let's create a data frame, and then let's give it a label to each column on top. और अभी कोई टाइमिंग नहीं देखेंगे हम लोग. We just want to create the object because I want to play with the sequence now. And then the next bit is all about just, it can give you how to find the sum of a number, how to find the mean, how to find the sum of one column, how to find sum through the rows. So basic simple operations on arrays can be done quickly. जब आप लोग ready हो मुझे कहिएगा, and then we'll move next. Ready? You have got a data frame object and you have added a column to it. Good. One person is ready. Another one ready. Now if you look at your DF, your data, it looks like a sequence of numbers, right? There should be 9 rows and 4 columns to it. That could as well represent a database which we have read from the financial market. Okay. So the first thing which I might like to do is just find simple statistical measures which would be easy for me to do. Should I move on? Anybody wants me to keep holding this slide, or you guys are okay? Unless I get a nod from everyone. Second row, first column. Are you guys okay? And third row, guys? Okay? Good. Now in a time sequence data, we often have some sort of time index. So right now your index will be 0, 1, 2, 3. So if you look at your index is 0 to 9, right? Let's change that index to some form of a times date stamps. Okay. And let's give it a date which ranges from one person and has got 9 periods in it. So now if you are with me, you should have got a 9 column 4 rows, but the index is now a timed index rather than just some numbers. Okay. Okay, what happened? Computer died? Power cable चाहिए? A solution might be if in future for you guys to sit in just one column so that we can access the wall things. So if you have already got till this point, now you have got a time series data. What we would like to do next is to do some maths on it. There's other things which you can do. You can find the average, you can find the log data. But what would be interesting to see if we can plot some of it as to how it behaves. Okay. So come some plots the cumulative addition, so it adds each number, so it should theoretically be linearly going up number. So we should be able to get bar plots as well as a timed plot after doing this exercise. And now we'll go around checking how you guys have got up to it. I'll let you figure out is there a syntax error. क्या हुआ? कोई syntax error आया क्या? Okay, I'll let you figure that out. What you guys? Oh yes, that's looking like now a financial data, right? Something is happening. You can't plot. Good. It's looking like some financial data. It could as well be performance of a stock, right? Now I know I've started very easily, but you will see very soon we are jumping into. Okay. So we have not defined DF, but look, पिछले. So we created DF paid off. Okay, so you should have stopped here itself. Nahi, if nothing works, stop me then and there. Okay, so that I will come and have a look. That's where it should be random dot standard. It's not random standard, it's random dot standard. Try. See if it runs. ED is not different. Did you import? Ah, okay, you imported. Okay, now let's do the next one. Okay, okay. Let's then plot the numbers, and then I will ask them if we are going very fast or slow. So guys, after we have got nice looking waveform, okay, so oopsie, sorry. So that's the time series. Show me the bar plots as well. Okay. Oh, and then we will take a tea break after this. Okay. So have you got the sequency data? And it all of a sudden looks like a actual bank data, right? And we've started with random numbers. The beauty of data engineering is you can show nice graphs without having any actual freaking data behind you. So now you know whenever you try to open a bank account and then they show ki return itna milega aapko, how it's easy to create that. We haven't done any financial analysis till now, but क्या हो रहा है भाई लोग यहाँ पर? Okay, you have got everything increasing. बड़ा अच्छा share price है भाई. नहीं आपने डिफरेंट रैंडम नंबर लिया?
दीदी ने बोला कि डिबग कर दो तो ऐसा है
ठीक है, it looks like a financial data. So rather than giving them financial data, I want to create something which looks like one. Okay. DF नहीं define किया? Okay, fine. But you know what to do, I guess. Right, guys. So all of those who have got it, will stop and take a break now. Can we? And now you have to tell me because I have been going very slow this morning, right? Should I go faster and assume you will be able to do this on your own, or still we should see each one of them? I could have just come straight to this saying, ये सब आप कर ही सकते हैं और हम ऐसा ग्राफ में फॉर्म होगा. You have to tell me मैं मुझे क्या करना है. Faster जाओ, ठीक चल रही है, या फिर your call. चाय पियो उसके बाद अकल बंद हो गई है सबकी. are creating a random. So just do this part. Not this part, only part. This one. And then you can plot. अदरवाइज मैं अगले 3 महीने तक यहीं रहूँगा. Okay, were you able to get your time sequence? DF बन गया आपका? Did this as well? So you should be able to plot the data now. Okay, good. Okie dokie. So we looked at multi-column data. ये अटेंडेंस ले रहे हैं क्या आप सबका? अरे यार वो क्लासिक अटेंडेंस लेना चाहिए था ना. यस सर, प्रेजेंट सर वाला. ये हमारे यहाँ नहीं होता, सो आई मिस दैट थिंग. Good. Now let's talk about series data. So series is a single column data. You can either create it independently, or it could also be taken from the data frame itself. So you already have a data frame, right? So let's just take the second line, s is equal to df number 1. So that creates a series with just the first column of that data. Okay? And you can do the same thing again. You can find the mean, you can find the cumulative sum, you can plot the data, and so on and so forth. Let's just do the second one. I mean, pehla wala which we can create a series directly. Okay. So now I will move a bit faster. Now you know how I come and check everyone's machines. If anyone is lagging behind, stop me then and there. Okay. Don't wait for 2 slides later on. So नहीं जानना कुछ या फिर नहीं कर पाना कुछ क्राइम नहीं है, बट नहीं बताना जरूर क्राइम है. Okie dokie, moving on then. So let's think something else when it comes to financial data. So our data frame object which we have created, DF, looks like a financial data. Okay, we have seen its sequence, we have seen the graph forms which it does. Let's now try to see. So mathematical comparison आप बहुत कर सकते हैं, right? I can find mean, you can put it in ascending order, descending order, ये सब आप कर सकते हैं. Let's try to do some text-based processing. Because financial data में सिर्फ numbers नहीं होते, text भी होता है. And one of the text which often appears is the quarter data. कई बार banks आपको interest quarterly देते हैं, right? Rather than monthly analysis, we do quarterly analysis. So let's add a column to our DF. So we're still dealing with the same object जो हमने शुरू किया था, called quarter column. Okay? And we're giving some randomized quarter data here. Okay. Then what we can do is we can group the data based on its column basis. So some facial features are suggesting they are lost. Now what we are might be interested in कि per quarter में हमको कितना profit हो रहा है, या what's the minimum sale in a particular quarter. These might be sales figures. So I can now classify the whole data frame with groups and find their mean, max, or do some sort of aggregation there. So I'll come around and like to have the response of the last line. So whenever you have got the last line ready, call me. So you can see for each column, now we have divided it based on a text data, right? Q1, Q2 text, they were string, they're not numbers. But we can still bring things which have got similar together and then do statistical analysis on that. So Q1 could be quarter 1, quarter 2. So now we could do analysis. So now that we have done grouping by text, we can find हर quarter में हमारा profit minimum sale कितना था, maximum sale कितना था, and so on. Okay? आपको देखने की ज़रूरत नहीं है. So, अगर कर सकते हैं, so quite often when you are a financial institution, you want to see पिछले साल के quarter का इस साल के quarter के अनुसार क्या change हुआ है. That's a good question. I will reply this for everyone. So it's a very good question here. Why am I grouping things based on quarters? Now remember yesterday we started talking कि data में seasonality हो सकती है, right? तो पिछले साल कितने ठंडा पड़ा compared to इस साल के. So if I'm in January and I want to know the temperature data, I'm not comparing it to December, I'm comparing it to last year January or the year before that. So banks quite often operate in quarter domains. In this quarter, how did I perform compared to previous quarter? And how did I perform compared to the quarter last year? Right? And इसलिए हम ये analysis कर रहे हैं. So you have got min max per quarter. Okay? Good. Sorry? Good. Carry on. What about you? So next काम कर रहा है. Good, brilliant. So I think everyone has got it running. What about you there? मेरी आंखें तेज नहीं हुई हैं, but I can see there is a column. There are some numbers in the column, so I will believe you for it. एक और exercise किया जाए इस पर finally. So the other thing which we might be interested in is where we are making profit or loss, or to be able to search in this big sequence of numbers with different criteria. Okay, so very simple. We'll just create a new data set. This again a random, or actually we can use the same one rather than creating a new one. Let's use the same thing. Okay. Here I have created a new one and I have called the columns X and Y. Let's just use जो DF जो आपके पास है उसी को use करें. And see if you can do these kind of searches in the last 3 lines here. So let's take any 2 columns and see if you can search together. What are the columns which are higher? So there are 2 things which we might be interested in. Where something is meeting this criteria. So a criteria here is say X is bigger than 0, or what are the names of columns in your case? Number 1, number 2, right? So let's see where is number 1 bigger than 0 and number 2 is less than 0. We can give 2 set of criteria. So now before you do that, just listen to me. So the result of these searches tells you what are the locations where this criteria is met. Quite often we need to know the number at that location as well. And then there are 2 ways to do it. Either you can do a Boolean series object. So you can create a series object. So look at this line where this gives me the location of that particular object where this thing has happened, and then at that location what is the DF number, or you can use the query object as well. Okay. So just to any one of these, let's pick DF bigger than 0.5, and then we move on to the next one. So let's write DF of number 1 bigger than 0.5, and it should give you all the locations where आप दोनों का चेहरा बता रहा है कि हम कहाँ खो गए हैं, तो आप लोग मुझे क्यों नहीं बुला रहे हैं? कोलाडो नहीं काम कर रहा है, इसलिए तो मैं कह रहा था कंप्यूटर पर काम करने को. Anyway, let's see. आप फिर से शुरू कर रहे हैं क्या? Can I have a look? Can I bring it here? Can I take your computer? नहीं आप बैठो रहो, कंप्यूटर मूव कर जाएगा. So ग्रुप ही नहीं है मैडम, ग्रुप बाई है. That should do the job. You had written groupie. It's group by. Okay, there was a syntax error. You guys are okay? Okay. So this was just a test of what can be done. We will need it again later on, and तब जब जरूरत पड़ेगा आपके errors हो रहा है, then we will do it. Okay, changing the topic completely. So now we have learnt about what data types we could use, what are the things we could perform. Okay, so keep your DF aside for a change. The next thing which we need to do is to visualize it. क्योंकि remember जब हम लोग just sequence of numbers बताए, they were not interesting. The moment you got your bar chart, that started looking much more fun. It was still a random number sequence, but bar chart and the graphic visualization looked of much fun. So now Python does provide a number of different approaches. कोई दरवाजा बंद कर देगा please. So I have an OCD of noise. So I can deal with student noise, but you know the लोग जब walk करते हैं, that noise affects my line of thought. So very basically we can use matplotlib. The disadvantage of matplotlib is it produces a PNG or a JPG image, right? Which is good enough for most applications, but it's not interactive. You can't do anything else with that image. So अगर आपको this match image लेके save करना है, that's perfectly fine. Other one is Plotly, which allows you to have some more interactive features. And then there is Cufflinks, which also integrates Plotly with pandas data frame. Okay. So the operation is fairly simple. We're not going to do it now because you have already plotted something by now. So essentially what you do is you import matplotlib, and then you can do various plotting operations. So let's do some random number plotting here. So I've done a very, very simple task. I'm not going to bother you with doing this thing unless you don't understand. I've just imported the library, created a random number sequence, and just plotted it. Okay. Of course, there are standard things which you can do. You can play with colors and axes. You can change things. And you can create histograms. So I ran it a bit fast. Let's see how many of you can. Now you guys create a sequence of 1,000 random numbers and plot its histogram. Or you already have your DF. See if you can do a histogram of DF. Other option, either create a series of 1,000 numbers and plot his histogram, and you can import these two here. So import map. Excuse me. So create a sequence of random numbers, but this time create 1,000 random number and just plot its histogram. May I? We're still working with the previous one. नहीं आप matplotlib use कर रही हैं. Fair enough. What are you up to? Data frame क्यों create करो? Just create a normal object. Right? Just y is equal to np dot random. We can deal with data frames as well, but I want to keep things a bit simple now. np dot. Wait. This is where you're doing a mistake. So आप सब कुछ type कर रही हैं, right? It automatically gives you. So just write few and standard tab. So tab is your best friend when it comes to programming. Okay? So most people who have never done programming do not know why the tab key is there on a keyboard. Agreed? It's only when you start typing things then you see the advantage. I hope you guys are using tab for completion of your sentence structures. Working? Okay, now plot the histogram. So plt.hist. Good, nice histogram. Okay. What about you guys? You have just plotted a number, now plot its histogram. So what is histogram? Have you come across them? Class 10th में तो पढ़ाए होंगे लोग. What about you? Oh, but there are too many seeds. So reduce the number of bins. So ये छोटे छोटे bins में divide कर रहा है, right? Let's just have 3 or 4 or 5 bins. Okay? You're an MTech student, right? You know? Okay. Fine. Then I will look at it. MTech वालों को नहीं बताऊँ. Okay? So now you have just plotted random. So what kind of random number did we select? So what kind of distribution is it? Is it wide distribution or Gaussian distribution? So increase the number of elements there, the number of elements, and then see whether it's a, not the seed. How many your what's the number? How many numbers do you have in your series? Let's take 1,000 and then see. So the question then is for you guys. You guys have created a random number, right? So some of you would have got a Gaussian distribution. So it should have a Gaussian spread. Some of you might get a normal spread. But has everyone got a Gaussian spread? कैसा है spread आपका? In YouTube it's not audible. You are here, right? Okay, fair enough. I'm using column mic, am I not? Okay. I hope I'm using the mic. Is it okay now? And let's see when I come to this person, still okay? Fine. I've got a blank screen. But there's no histogram there. So what are your numbers? Are they random numbers or are they the... So show me the number. Show me your X. Just show me your X or Y. What's number? So you have a Y. Just list the numbers to me. नहीं, last line में जाइए. Just go to the last line. Just go to the last. Type Y. That's it. Enter. So these are the numbers which you have. Let me show you how what histogram किसका किया है आपने. आपने histogram X का किया है. What is X? X is the length of Y. So if you do a histogram of a series of uniform same number, it will be a uniform number. Okay? Happy? Good. Now how many numbers did you take? 100? How many did you guys take? 30. Doesn't look a very good histogram, does it? And that immediately tells us if you're going to do any statistical data processing, we need a large number of numbers. So let's take 1,000 number and then let's see if the histogram looks nice. So this is an example of a bad histogram. It doesn't, by looking at the histogram, I can't tell any statistical feature of it. Now here's the beauty. With Matplotlib, you can do quite a lot of 3D type of visualization as well. But most of the time, business and finance people are fairly happy with 2D plots. So हमें कोई 3D plotting सीखने की ज़रूरत है. There are sequences when you are looking at optimization of stocks and other things with 3D की ज़रूरत पड़ेगी. But as of now, 2D plotting is good enough. Now we're not going to do this, but just as a reminder, a lot of financial data is in CSV format, a comma separated file. Now it is used, the beauty of CSV file is virtually every operating system can read it. The drawback of it is there is no standard template. So you can put any sort of numbers, any sort of incomplete databases, missing numbers, missing data. So all of these errors also end up in financial data series. To read that, Panda provides you the standard CSV file template. I'm not going to deal into this, but this is there on the slide. So in case we will need to read CSV, which we will need to do in the next exercise, and we can do it rapidly. Now, one criticism which people often do against Python is that it's slow compared to C or C++. Or खासकर university days में it's a classic question to ask, why is Python slow? Particularly for data analysis, financial data analysis, one criticism often said is we need loops because we have sequence of numbers and they're different type of numbers. And Python is slower in loops compared to C or C++. Okay. Another drawback is it's an interpreted language, but we can always convert it to a compiled language as well. So that feature is Python provides to us. Now let's look at loops, because we'll be using a number of loops in our future as to how we can make loops faster. Okay? And this will also answer the question which we answered right in the beginning. How was NumPy able to do things faster than normal list? Right in the beginning हमने यही किया था ना? We looked at a random number, we just created a random number, added random numbers, and all of you said NumPy is faster. Okay. So we have already done this thing. We have created a sequence of numbers. There's another way of doing it. Now I have, let's do this anyway. Let's find, because then we would like to compare two different ways of doing the same thing. So if you can create a new series of random numbers in a very simple brute force way of doing it in as a for loop. Okay, we know loops are slow. So as a pure for loop, and then see if you can find the average. So what we have now done is, rather than using the mean function of Python, I have created a function which finds the average of a series of numbers. And then I'm trying to find what is the time taken to do this average numbering. So it's a very simple for loop. I just go through from 0 to n, and I keep on adding a random number to it. At the end of it, I just take the average, divide s by n. So if you can copy these part and then find what's the time taken to do the average. And this we can then do the time it takes for each loop in this module. So is the question clear to all of you? And you will see what we are going to do next. We are next going to create the same sequence using NumPy and then find the time it takes to do that. So as soon as you are ready with your time, can somebody give me the time it took you to do this processing? So these are the numbers which I got on my machine. Let's see what numbers you guys get on your machine. Sorry? Millisecond for, and what's the time taken per loop? So that's by the next line you can, right? Plus or minus something. How many numbers are you taking as 10? Okay, 100,000. Okay, good. If I use NumPy vectorization after this, so this is exactly what you guys are doing right now, the first part, what you will find is I can significantly increase the speed of operation. So here I'm adding one at a time. So I'm taking a number, adding another random number to it, and adding another random number to it, and so on and so forth till I reach the end, and then I'm dividing it by the end to find the average. The alternative way is to ask NumPy is to create a sequence of number and just find its mean. Okay? If I do that, I'm significantly faster. So my time earlier was in my machine was 672 millisecond. It has now moved to 90.3 millisecond. Still faster than what we had earlier. Okay. What I would like you to then check is this. S.n bytes. The last line. So if we have created a so what are you getting? So if you follow with me, what you will find is the area required by NumPy array is significantly larger than the area, the size, the storage area of the simple list. So we get the timing advantage by giving up on storage. So do all of you have got the right? So we went from 100 lakh numbers to we increase the space requirement. Okay, right. Now this is a problem for us in financial time series. Our time series is already very large. We have got a huge amount of numbers to play with, and if we now further increase the storage requirement, our access will change. And remember yesterday we were talking about the stumbling block of all our new processing system is the memory fetch. right? Memory and processors, the transmission is not as fast as a processor and memory itself. Now there are alternatives. We can use better packages. We can integrate C with it. There is Python, which tries to make C and Python together. There is Numba. I will give you an example of using Numba. In the first, when we run something with Numba, the first iteration takes time to compile something. So the first iteration is slower. But once you have done the first time, the second time onwards, it becomes fairly fast. So here you can see I have run the same code. The first iteration took me 236 milliseconds. The second iterations onwards, it was fairly faster. So compared to my previous times where I was taking something like 90 milliseconds and I've got, I've increased my time performance. The first iteration went up to 230 milliseconds. But from the second iteration onwards, I'm fairly fast. And this is, these are the alternatives which you can play with. Okay. Good. Now let's get a bit more serious. Till now what we have dealt with are simple random number sequences. We have made them look like financial data, but we know they were not financial data. We're going to learn a bit about Monte Carlo simulation, which is extensively used. It's a statistical data analysis extensively used in banks or in financial institutions, but also used quite a lot in chip design, the kind of field which I come from. Okay. So we'll take a bit divergent view to look at non-financial business processes. Remember, till now we have been talking about financial business processes. However, those are not the only business processes we need to explore. Now, you guys have come across basic transistor theory in your first year. Right? Faces so that we're not happy with it, but they existed. Now, we have a problem with transistors that in one way we are able to put 1 billion transistors on a chip, but no two transistors are alike. So each transistor behaves differently, slightly differently to its neighboring transistor. Okay. So we see variations on one wafer. So on one wafer we have many transistors. Each transistor is different. But we also see variations from wafer to wafer. So if I make 10,000 chips on one wafer, another 10,000 chips another day, they are also very different. And this is actually part and parcel of nature. Nature does not produce two things of the same time. And this is where we as engineers are different to the natural engineer. Nature tried itself to make things which are different and hope that their differences will work collectively for the better good. We don't have that luxury. We can't sell 10 different TV screens saying कि ये वाला 36 इंच होगा, ये वाला शायद 37 या 38 इंच होगा, मार्केट नहीं लेगा हमसे. Okay? So we start with devices which are not uniform, but in the end we have to make a product which is exactly the same. So when we sell a processor, all processors should have the same or similar-ish clock speed. Now we generally end up having two different type of, two systematic variations are often quoted when it comes to chip design processes. One is, if I make all my transistors on one wafer, what is the difference between them, the internal difference? And other is, what is the difference from wafer to wafer, from lot to lot? Okay. Generally speaking, we model both of these as a zero mean Gaussian process. So they have got a fine fixed value, and then there is a distribution which come off the top, and any one of these number works on. And before we send our chip for fabrication, we undertake Monte Carlo simulation to understand what might be the spread of my output. I know I'm designing something for X performance, a gain of 5. I'm not going to gain a gain of 5. Am I going to get a gain between 4.9 and 5.1, or is it going to be between 2 and 10? This spread is of vital importance to the way I sell my product in the market. So all of you have done first year electrical engineering laboratory, right? You have come across resistors, the very simple, beautiful structures. And the last ring on the resistors talks about their tolerance. So when you make a 10 kilo ohm resistor, you don't get 10 kilo ohm, you get any spread on it. Okay? The smaller the spread, higher is the cost of the device. And it also happens in chip design. We do not get the exact same delay from every inverter or every flip-flop, or exactly same clock speed from every device. But as long as the overall performance is within bounds, within a certain boundary. So say I'm making resistors and I'm going to sell it as 10% resistors. As long as overall output from all the process sequences within that 10% boundary, I will be happy to live with that. Okay. Now, just to take a very divergent view, just we'll know a little bit about transistors. So some of you might recall, and we're only interested in metal oxide semiconductor field effect transistors right now. The transistors looked kinda like this. So it's a MOSFET transistor. They are on a p-type substrate, again made of silicon. And in this p-type substrate, we put two n-type doping. The length of the transistor is and then there is a gate structure here, my apology here, is the distance between these two n-type dope. And it could be another type of transistor. This is an n-type transistor we are talking, which forms an n-type channel. So length of the device is the length between this, and the width is how deep it is. Right? So it's a three-dimensional device. And generally you might have derived these equations in your university days as to what's the equation for the drain current of these transistors. So drain current in saturation comes out to be something like this. It's related to the width and length of the transistor. Okay? And VGS is the gate voltage. VT is a kind of an inherent threshold. The transistor does not become on till we have got applied a certain VTM. VT is the voltage which you apply, the gate voltage which you apply on this. Unless you reach the VT voltage, the transistor is switched off. Okay. Now, we were told, or you were told, that VT is a constant. Same here. Once I have made my width and length, they are kind of constant. But what actually happens is what's the typical size of a transistor we are making in a modern day microprocessor? So yesterday I asked you to check the specification of electronics which you have. So processor of your mobile phone, how many gates does it have? Has looked at that? सर 4 बजे तक तो आप ही बोर कर रहे थे, उसके बाद तो सांस लेने का समय मिला. 5 nanometer, that's the state of the art process. So we're looking at very small devices, right? Even if I'm looking a couple of generation older, they're still around 28 nanometer or 90 nanometer devices. They're fairly small. Do you have any idea how big a nanometer is? How big is a micrometer? So your hair, which is the thinnest thing which I can see in this room right now, is 100 micrometer thick. Okay? So it's 100 micrometer thick, your single. Divide the thickness of your hair by 1,000 times, and then you have got 100 nanometer. So these are the size of transistors we are manufacturing them. We cannot make exactly the same width. So when you claim to say that I'm making a transistor which is, say, let's take a bigger geometry process, 350 nanometer big length. The length is 350 nanometer. So we do not get a sharp cut length. I mean, we don't get sharp, we get like curvy, bendy diffusions. So the length is not a uniform number, and from each transistor we get slight variations in the length fabric. Because the way we form this is we put gases and they diffuse in the substrate. So diffusion is a random process, right? As gas molecules go in, they're never going to follow a uniform task. So as it's a random process, we get a randomly distributed width and length of the transistor. And there lies our problem. We had a very simple equation here which dependent on two constants, K and W, Vt, and width and length of the transistor. And I make all my transistors of exactly same width and length. They're not going to get exactly same width and length. That much I know. What I also know is if I make all the transistors of people, my foundry or the fabrication partner would have made a large number of transistors with same width and length on a chip and measured their actual width and length or measured their performance. And from there would have come up with the spread which I expect to see. And the spread also happens in Vt, which is the threshold voltage of transistor. It's also not a constant. So electronics is a beautiful subject. When we teach students initially that this is the equation of operation and these are constant numbers, and 2 semesters later we tell them nothing is constant in our field. We also start with something like, you might have dealt with operational amplifiers, op amps, and we teach you ideal op amp which has got zero output resistance, infinite input impedance, and 2 semesters later we'll tell you zero and infinity does not exist in physical circuits. You cannot have zero output resistance. Every wire will have a finite resistance. You cannot have infinite input impedance. There will be a finite impedance. It will be high, but it won't be infinite. This is why the subject is beautiful. We change your entire mindset every semester. So we have a problem here. So as I said, no two transistors are alike. We now model these variations in transistor operations using these two parameters, the Vt, the threshold voltage, and beta, which is the parameter here, Kw by L. Okay. And we then say is that they have got a spread, which is generally a Gaussian variation, which is somehow dependent on the width and length of the transistor which we are making, inversely proportional to. And that's a bit logical. Smaller the transistor you make, more will be the effect of the variations, right? I make bigger devices, I will have less error in making them. So we have these spreads now, but these are the spread on each transistor. I am making a circuit with say 20 transistors. How is my circuit going to behave? Now the circuit output and input have got a non-linear relationship between. Okay, you could make a linear circuit as well. But this is already a non-linear equation here. Vt goes inside Vt square. Right? So relationship between, not between input, relationship between my transistor parameters and output is going to be a non-linear, fairly complex function. Okay. So how do I predict how my device is going to be? Now here is a very simple 4-bit adder response. What you can see, because of these variations, all my waveforms don't rise at the same time. They have got different slope of rising and they have got different fall time. Now if I make, say, these are 6 different adders, the only where I can be sure of its adder operation is somewhere here. So if I'm here in between these two numbers, I'm not sure if my adder is already working or not. And similarly here. So every time I do a clock transition, I have to give some time to be confirmed that whatever adders have been made, they are performing within performance. So now I'm cutting down on my clock speed. So I designed something to be very fast. It is very fast, but I don't know exactly when it's rising and falling, which means I have to give some buffer to myself that in this region don't operate while the system, so if I have 10 adders, all of the 10 adders will give me the same result. Okay? And I will only trust the data from here. Now there may be many ways of doing this. We could either manufacture the chip, many 10,000s of these chips, test each one of them, and then determine how good or bad my process is. Chip making is a costly business. One mistake can kill your company completely. Intel once did an FD for the divide by zero error and it costed them a huge amount of money in the market. I can't afford to take that risk. The electronics market moves very fast. Right? Your mobile phones transistors and mobile phone chips virtually every year changes with performance. In couple of years, each of electronics looks like an ancient electronics. So I don't have the luxury to be manufacturing many different chips and testing each one of them. So what I do is I do Monte Carlo simulations. And the way we do it, so you might have done simple transistor simulation to say, okay, here are the input, this is the output we get. Now we go back and say, okay, each transistor has got a beta and VT, which we know has a distribution. So say I have 10 transistors, I have 10 VTs, 10 threshold voltages, which could be anywhere from this distribution. I pick each one of them, so each transistor has one number from these distributions. So say that's my distribution, or this is the output distribution, my apologies. But if I have a distribution, in one simulation I take first transistor to have a VT of say 1 VT, the second transistor to have a second VT, the third transistor to have a third VT. So each transistor gets its own VT. I do the simulation, I get a result. I repeat the same simulation again by changing the VT of each transistor, and I get another result. If I do this experiment large number of times, and the large number of times is dependent on the number of input parameters I have, such that the spread of each parameter over these large number of time becomes Gaussian or mimics its natural spread, then the output distribution of the result will match the output distribution of the circuits which I will make from these complex circuits. So Monte Carlo simulation helps me understand the spread of my output when the parameters which are operating on my input have a spread of their own and I don't know the exact behavior. Okay. A very good example for doing this is your cameras. So all of you have got cameras with you, and when you try to take a picture of a white object, you do get a white image. So my PhD was on making cameras. So this is a result from my camera. It's a 200 by 100 pixel camera, and this is when I was trying to take image of a uniform object. That's not a uniform image. Right? Okay, I've shown it darkened so that it's visible on a white background. You can see it's noisy, but you can see there's a pattern in the noise. So there's a columnar, there's a row-wise distribution. I mean, the image has been shifted by 90 degrees. So each column has got a noise, and inside this there is a noisy pattern as well. This is what we call as fixed pattern noise. It's not a temporal noise. It does not change from every simulation. It stays on the system. Okay? Each camera on its own have got a different noise. Even though the two cameras have been made in the same process, they will have a different noise. If you're coming from a computer science background, you might say, okay, fine, the noise remains the same. So basically the noise superimposes itself on every image I take. So why don't I measure this noise and then correct for it? Actually, all of your cameras take at least 2 pictures or do some sort of double sampling. The same scene is sampled 2 times to remove the effect of such noises. Okay, so we don't take a single picture at any one frame, or at least there is a differential operation which is going on. Now, I've told you a lot about use of Monte Carlo in transistor. Monte Carlo is also used to understand how my market will behave, or how my financial instrument will behave. Now say I'm trying to buy a stock in the Bombay Stock Exchange or the London Stock Exchange, and I will have a large number of stock portfolios with me. How will my overall financial situation look like in few years from now? I know each stock could go up and down. So some stocks have got higher volatility. So say for example, recently, well, oil used to be a stable stock, but thanks to all the wars going on in the world, it is also not become, but it is generally a stable stock because we know people will need oil to buy. Right? So the demand is always there unless electric cars kill them all. Some stocks, for example, technology stocks could be very volatile. They could become very high or they could crash completely. Okay. Some stocks have daily fluctuations or seasonal fluctuations. So say a company which is making orange juice, its stock price is dependent on how good the orange market has been that year. Okay. So I've got good. Okay, we'll wind up in 10 minutes. Yeah, sure, we'll wind up in 10 minutes. Or just raise your hand. You don't need to come in. Okay. So now there lies a problem. So you're doing one simulation till now, and now I'm asking you to do a large number of simulation, often dealing in thousands or 10,000 simulation of the same system. So one simulation was taking time, and now we are saying we'll be do a large number of simulation on the same thing. So I took some time to explain how Monte Carlo simulation takes place. In the second half, we are going to use it in a very complex mathematical operator to understand the European put option. Okay, we'll be dealing with Black-Scholes-Martin equation. Black-Scholes-Merton equation. I have typed it in it has become Black-Scholes, it's Black-Scholes-Merton equation. So it's a stochastic differential equation. I'm not going to spend energy trying to understand how the equation behaves, because most of you have not done stochastic integral calculus till now. So we'll assume that the equation exists. We will try to write the Python code for it and see if we can do Monte Carlo simulation and how long it takes. Okay. So with that, we'll stop now and we'll try to appreciate the behavior of this in the second half of the day. So I was hoping we'll finish all this Python in the morning. So we will do a bit of Monte Carlo simulation, and then we will do a bit of time series analysis in the second half of the day, and we'll come back to neural networks to see how neural networks are better or can work on the same time series data. Okay, with that we'll stop for lunch. Thank you.
According to our schedule, we have planned to start it, but we can start earlier also.
जो टाइम नहीं 3 बजे शुरू करते हैं.
Sorry.
Beauty is this, we'll go as far as we go. Actually, coming to you, आप कह रहे थे ना कि सवेरे जगना थोड़ा मुश्किल होता है. I think we should have done the whole session from 5 o'clock in the evening. 5 से 9, right? नहीं? 3 से 7? Should we do that? नहीं, but timing बाहर चली गई है ना, we can't change the timing. It might be better for future courses if you're inviting somebody from Western world who is suffering jet lag. You do a 4-hour slot in the afternoon. Done.
We can try so next time. Sure.
So my evening plan is to go and watch a hockey match today. Is anyone interested in hockey? Can somebody tell me what's happening here? Is it a good team? Which team should I back up? I think the match today is between Vizag and Uttar Pradesh.
Where both the jerseys? The one which will be wearing
I am wearing my football jersey. So I just realized after I walked out, do you know what jersey this is?
the referees. You are a referee?
So this is my referee's t-shirt.
Okay.
Now I don't look like a referee anymore because I can't run, but I am a trained football ref.
The problem is a ref has to run, do you know, on an average, if you do a professional match, you run 12 kilometers in 90 minutes.
At least 12.
Because if you're, so you all see the players running around, right?
Yeah.
Refs run corner to corner.
Yes.
So hockey में refs stand on their ground.
हाँ.
Football refs run corner to corner. So एक जमाने में मैं वो 12 किलोमीटर दौड़ पाता था.
I promised we will do Monte Carlo simulation, but considering we only have 1.5, about 2 hours today, let's revisit Monte Carlo simulation a bit later. And first do this, which we can finish, and then we can start doing time series analysis. So, what we have seen today, are you all with me? Is that you're happy with me sitting here, right? There's only so much standing work I can do. What we have seen today is that data flows, data has got a time dependency. If not dependency, it has got some form of relationship. So let's revisit our good old British pound to Indian rupees data and see what we can do from this data. Okay? So what do we see here? What kind of pattern can we expect to see in a time series? So to start with, it could be a fixed data, or it could be a fixed around a mean value. So there is some sort of a level data. Generally it's constant if there are no other patterns. Now here I have plotted the US dollar to Chinese yuan. That looks fairly, I mean, okay, there are some jumps, but generally speaking it's fairly linear. Why is that? When we looked at the Indian currency, it fluctuates on a pretty much on a daily basis. What's happening here? So looking at these two data, and you know how market works, market moves every day. What could you infer from these two? और ऐसा तो नहीं है कि चाइना की इकोनॉमी चेंज नहीं करती. देखो, this is just 1 month data, last महीने का. So why is Chinese figures very constant against US dollar? ठीक है, even 1 month का भी लेंगे अगर, तो I mean you can look in any 1 month fluctuation, Indian currency will still be going up and down. Okay, let's take another data. आपको 10 साल चाहिए था? You got, so this is the US dollar to Emirati dirham. Why is it flatlined? And this is flatlined from 2017. So I'll give you a hint. Indian rupees also used to be similar. Till about, I think till the times of Manmohan Singh, when he was the finance minister. So some currencies are not freely tradable in the market. They do not follow the market. The government determines their rate. So the United Arab Emirates dirham is pegged to the US dollar. So as the dollar moves, it moves. It's not pegged to its own economy. Right? You can play that game, or you can allow the economy to be worse off. So essentially, if Indian rupees also moved with US dollar, your salary remains fixed, but the thing which you are buying would be in a bit different. Right? So we moved to a freely convertible rupees, I think around Manmohan Singh's time. I might be wrong, don't take my word for that. Right? However, in these data, you can see there is a level. I mean, they're constantly around mean, or there might be a mean and some noise on top of that. So that could be one thing which could be there in a time series data. The other thing which could be would be a trend, either it's going up or going down. Right? And from a first order mathematical analysis, a trend is the slope of a function. Right? You might think I'm talking about a high school maths. This was a question asked to me when I applied to become an investment banker in a big bank. They literally plotted shares which were literally going up. And they asked me what will be the best curve to fit. And I kept on thinking for 5 minutes, it can't be that easy. These guys are going to pay me a lot of money. It can't be y is equal to mx plus c. But that's what they were interested in. So what are we having here? This we're looking at US dollar to Canadian dollar. It went downwards for a long period of time. And you can see if I look at the average data, there is a constant slope. Okay? Good. The other thing which we could have, the trend need not be linear. It could be exponential, and I'm sure all of you guys have seen a graph like this. You were alive during the COVID times, right? The exponential rise. I think everybody figured out what an exponential curve is during coronavirus time. The other thing we could have is seasonal variation. So we could have periodic variations, which could be hourly, daily, weekly, even quarterly variations, and this could be caused by natural sources. So this is for matter, I've just taken the data from World Health Organization again today. And I plotted the number of flu-like syndromes. Now when do we get more flu? Which month of the year do people get more ill? June, July? In the winters? Or when pollen count is high? सर्दियों में सर्दी नाम ही है उस बीमारी का, right? So, which is natural that in winter we get higher numbers of people suffering from flu. There's also a strange correlation. In winter we have higher number of deaths of elderly people. Not to make fun of, but अगर आप जून दिसंबर में देखें, the number of Indian senior people who died, including Manmohan Singh and others, was high. Right? So these variations could be natural, could be man-made, or could even be of unknown origin, but as long as we see there is some residual fluctuation. And in the end of it, we have random fluctuation, जिनका कोई माई बाप नहीं होता. Right? So we could as well assume them as some Brownian motion. They're irregular and they're unpredictable. So out here we can see we have got slopes, but we also have random fluctuations on top of that. Sometimes we also talk about cyclic movements. Now these are very similar to seasonal fluctuation. Only thing is that generally take over a longer period of time, to an year or more. Okay, and they are more tied to business decisions or long-term business cycles. We have done something in a year, we are getting some fluctuation results. Okay. Right. So how are we going to model these? So mathematically we could have an additive force or a multiplicative force, right? We could add something or multiply this by it. So if we do the very simple model, and so the level model could just be my output, or whatever is going to happen, or whatever is happening, it's just an average plus some noise on it. So E is my noise, A is the average. So that will be the level model. Things are fairly level. The trend model would be, okay, I have got a level, plus there is a trend which is dependent on time. So A plus BT kind of model, like first order linear approximation, plus some error, some noise which will be on top of that. We could also have a seasonal model wherein we have got an average, and on top of that there is a seasonal pattern. It could be sinusoidal or some other pattern which is imposed plus some noise on it. Okay? And we could have a mix and match of these models. So entire time series analysis follows to these 4 steps. So we have a time series data. We have to select an appropriate underlying model. Which one of these or which one mixture of these will better mimic the data. Then estimate the values of the parameter. अगर हमने एक assume किया it's a linear line, so we have to assume the value of the slope and the intercept. Okay? And then forecast based on this model, but then keep on revising your model performance, and that could mean revise your parameters as well as revise your style of the model which you have selected. आप assume कर रहे थे कि share prices हमेशा ऊपर जाएंगे, which is technically not feasible. No share price can reach infinity. Well, one hopes. Okay. So in order to forecast, the thing which we need to see is, if you're doing it just pure time series forecast, how important is history for you? कितने दिनों की पहले की history आप लेना चाहते हैं? So you could be very naive and say, my history doesn't matter. All that matters कि पिछले महीने मैंने 100 रुपए खर्च किए थे, तो इस महीने भी 100 रुपए ही खर्च करूँगा. Okay? Now you all have your time series data. Okay, so we are going to actually before I ask you to submit, try to do this on your own days to see if there is any seasonal variation, if there is any patterning there. But more importantly, so you could have a very naive forecast which assumes my next, going to happen next is dependent on what I have done this month, or whatever I have sold this month, that's what is going to determine my future. Okay? Plus some random noise on top of it. Or I could think the entire history is important to me. Whatever is going to happen to me is based on whatever has happened in past. In which case, we call it a cumulative forecast. You consider everything which is going to happen. And somewhere in between, you could say, okay, not the entire history, a part of the history is important. Or you could say, the more recent things which are there, they are more important than things which have happened in many, many years ago. Understandable? So if I compare these two, the maths model becomes fairly simple. If I just look at the level-based forecasting, we're not going to very complex forecasting. If I assume my level is, all my data accumulates to mean. So this is again, which comes to your monthly expenditure. You might assume in 2 years' time, your actual monthly expenditure hasn't gone up. It goes up a month, but will come down a month. So there is an average thing. So that will be very easy to find. You just find the average over the given time period. And that's the complex maths which I have. It's an average finding. Or you could say, don't care. Whatever is my last figure, I take that figure and assume the same will happen. There will be some random perturbation on it, but fair and fixing. Now the difference between these two is this. The cumulative forecast is what we call is a calm forecast. So it is considering a lot of financial data, so it does not respond to an immediate jump. Okay? The naive is nervous forecast. पिछले महीने बहुत ज़्यादा खर्चा किए थे. Immediately send a letter or in nowadays telegram to your parents कि भैया 100 रुपए ज़्यादा भेजिएगा इस साल. Right? But naive forecast also is very good to respond to changes. Something has happened. Okay? My laptop has died. We need to buy a new one. And if you buy a new laptop, अगर Apple के world में हो तो you need to buy all the accessories new as well. So naive forecast is actually not bad when you have got big changes happening in your market. Good. And the one in between are also we take X number of samples before that. So we take M samples before our current history to know these M samples are important for me to tell my future. And this is now you have to play a game. How many M samples? If you go too far back in the history, it's almost the same as cumulative forecast. You take the entire history. If you take too small a history, it's almost very close to the naive forecast. Okay? So it makes, if you take too small a history, your forecast is going to be nervous. If you take too much of a history, you are going to have, you are going to average out all the noise, but you'll also miss any changes required, any step changes which has happened in the system. Good. So that's the background of time series analysis. And now we will go back to Python and do some of it. So we stopped. So we can go and do simple analysis. So one is modeling. There is a time series data, we model it. The other is data is never that simple. Okay, I mean it's never static, it's no. So let's try to create a complex data and try to come and do some sort of regression for it. Right? Forecast करने जा रहे हैं, so regressive forecast करेंगे, least mean square forecast करेंगे. So once again, now we go back to Python and start doing a code. Now which we will do is we'll create a very simple function, okay, which is essentially it's a linear function going upwards, and we multiply this with a sinusoidal x. Okay. So that's the kind of response. Can somebody close the door, please? So if you are able, you don't even need to do def fx, you can just write this function straight up and plot this function, you will get a response like this. So essentially what I have done is I have created a linear space of numbers, multiplied that with a sign, and we have got this thing. Okay? So So as soon as we have got the basic number, we'll start with the next sequence. So the idea will be, this is what we have seen from the market, and we have to understand what function fits it. And we'll start with simple regression, and we'll end up with neural networks to approximate this. And I will wait for a minute because we really need to have this working. Rather than defining it in y is def fx, you can just write y is equal to np time np dot sine x plus 0.5x. I will walk around. What? Just show what x is. We should have got a semicolon here. This is odd. May I? So you guys have learned to live with low lighting to battery life बढ़ाने के लिए. अच्छा ये keep use कर रहे हो. Let's see what my x is. Okay. Okay. Plot. Pnt dot plot. Okay. What about you guys? It can't run that long. Check what x is. She has got it, so it can't be wrong. You've got it? Good. What about you guys there? Here we have got a sinusoidal waveform. Good. So that's the data which the market has thrown at us. And we can start by assuming we know nothing about it. We can try to approximate it as, what will be the simplest approximation for this? Kinda looks like a straight line with some noise built on top of that, right? So If you really want a fancy curve, you can add few more things here. You can add labels, plots, and other things. And this is, I'll leave it in slides for you to play with. And so I have created a function to do that. We don't need to do that now. Okay. So we can use the polyfit method of NumPy to fit a polynomial to it. We created it using a sinusoidal function. We can approximate it as a polynomial, and the simplest polynomial we can approximate it will be y is equal to a plus bx. So I've already given you the code. Let's try to do a polyfit. So polyfit extracts the parameters which will be in that fit. Now I have said that, okay, x is my input, fx is my y output. So that's the relationship I want to find. I want to find a relationship, a polynomial of first degree. And once I have found the polynomial using this res, try to evaluate a value. And then I plot both of these two together. So just write the first two lines of the code, and then you don't need to write the plotting. Plotting we will see in this case. So this is, we're very much doing a least square minimization here. And I'm not going into the depth of least square minimization as you are second year students, so just trust me for a second. So if you have done things properly, this is what you will get. You will get a straight line which tries to approximate this wave function. Okay. And this is not a very good fit, but it's not a bad fit. It kind of does the average fitting there. Okay. So anyone is having difficulty in this fitting? The create plot is using my plotting function. So you can just go for straight plot plt.plot if this causes any issue. Any luck? Do you want the create plot function as well? Okay. Just don't use the Y label or legend. I mean, okay, yeah, put Y label as well. Once we create it, we can use the same thing for multiple. Or is there a way to share code here? I could possibly put it online. Guys, if in doubt, if this code is too big, just write something as simple as this. Uh, oopsie daisy. That should also do the job. Is it doing the job? I need to walk again. I should be sitting in between and you guys should sit all around me so that I don't have to walk. Babu, oh, you're writing the whole thing. I can go back to it if you want. Can I? No, no, what I meant to say was don't write any of this. Okay? Just do this. Take it. Let's delete. Are you calling it y or are you calling f of x? Function क्या दे रहा है? f of x दे रहा है ना? So this is not needed. Okay, we're just doing two simple plots. Hmm? Did you import numpy? Yes, you have. And importing. Can I have a look at the first line of your code, please? Just a second. I think he has done it.
I've not done those yet.
So PyLab, what are you importing? Okay, you know what? You're having an error here. Why? Okay, plot may not work. Let's see if is this line which is causing the problem or the other line? Can you type it again, please? And I'll be back to see. Got it? So this is a first order fit. It's not a very good fit. So what should we do next? Well, we have a degree here, so most probably that is telling us to do a second order. Let's try with degree being 2. Because now it's just press the upper key once and you will get the whole thing. Sorry, the top arrow key and you should be fine. So if that is not working, take it from matplotlib. That should be there. Import. So there is a standard connotation of relationship. Your partner decides to call you when you are in the lecture, not during the 2 hours lunch break you had. So my wife manages to find the right time to call me. What's happening? Just show me what's happening. That's not a sign. So you're not working on my problem then.
Raman?
So why you are getting a pure sinusoidal function? That's not. So what did you multiply it with? 0.5 times x. This is what we thought. Run it again.
No, it's coming.
What happens? Tell me. Does it give a better fit or does it not give a better fit? It doesn't. क्या हो रहा है दिखाइए. Okay, let's try higher degrees. Let's go for degree 5. So remember we took a first order function and we added a sinusoid series to it. So sine का Taylor series में second order function आता है कि नहीं आता है? क्यूब आता है ना? Okay. Five looks better. So I went for a 6th order fit and this is what I got. Still not terribly good. I mean, I still have some noise. What if I go for a 7th order fit? Better? 7th looks as predicted, right? क्या हो रहा है बाबू? Still having matplot पे गड़बड़ा गया है. See if you can reinstall pyplot. Okay. If not, go to the online version of this. Okay. So what we realized, we can take a fairly simple function. What you did not look at is what is the value of my reg. So can you now see what reg is after 7th order fit? How many input parameters does it have? So this is essentially saying that we are now having a function which is doing your res0 plus res1 times x plus res2 times x square plus res2 times x cube till x to the power 6. So you should have got 7 different, an array with 7 elements there, right? Now that's a fairly complex computation for something which was very simple. To mimic this waveform, which we generated just using a sine, a linear series and a sinusoidal function, we are having 7th order polynomial. In one way, it says good that we can do a polynomial fit, hence Taylor series works. Has it been taught to you guys for second year students? Have you come across Taylor series? Good. A better way could be to see, hey, we knew there is a sinusoid here, right? अगर इस इक्वेशन में देखें तो एक साइनसॉइड जैसा दिख रहा है. So why don't we tell our regression system that there is a sinusoid in the system and try to put ourselves to that sinusoid? So I'm not asking you to do this thing, just trust my word for it. So I have created a third order linear approximation which goes something like this. And then I ask it to say, okay, the function has got np dot sin x and try to fit to that thing. So there is some sort of sinusoidal function here. And it does in a very quick regression method. Okay. Other thing which we could often do, so regression is very good when dealing with noise. Again, not going to ask you to do this. What I have now done is I have added some noise to my x variables. See, I've added a random noise of a certain length, and I've added another random noise to my y variable, and still done approximation, and I still do a fairly good fit. Okay, still a 7th order curve fit, but it is fairly immune to curve fits there. Now, this is what I would like you guys to do. So now we are doing so originally our list was sorted, right? Everything was monotonically increasing. Let's do an unsorted list and see if our regression still works. So I've given you another function now which has got it has got some random number plus it's randomly generated number. Let's see if you can, how does this looks like. Or actually, better still, I will leave that as a homework assignment to you. You should be able to do that. And there's another homework assignment. This is to look at cubic splines and interpolations. I will leave the slides for you. This is when we start looking at cubic splines. Because we haven't come across them, I will not discuss them too much in detail. What we will do is ask this question. So regression partly worked. It only worked because we use very high order polynomial for a very simple function. Or it was noisy. We didn't get very good results. Okay. So let's try to learn this. Till right now what we were doing is we're saying, okay, there is a mathematical operation which has got some form of relationship in between them. Now let's try to learn this using a neural network. I'm not going to tell you what the neural network is right now, but we're just going to use an MLP regressor here and see if a hidden layer of 3 hidden layers with 256 nodes can learn this code and can give me a fit. So try the first 4 lines of the code, and then we will see if it fits there. So today we will just learn. Tomorrow we will see the maths behind this MLP regressor. And once again, in place of create plot, we will use a simple plot. And I will start walking now. Where are you? Don't you have this package installed in your... It's not natural, it's neural. NEU. Yes. There you go. What about you? Okay. Is it learning? What have you? 3 into 256 initial learning. Acceleration. No. If you've got an error, that line is not working, right? Can you show me your X? And can you show me your y underscore? Okay, so let me try doing something here. Model dot fake. Oh, what happened? Got him. Minus 1 comma 1 y. To-do. Inconsistent number of samples. It's interesting. What is your x? Let's create a new x. Okay. And that's why. Yeah. Okay, because there is already a y existing from a previous iteration. Okay. So what we could do, y is equal to f of x. Got it. So you had a y from a previous iteration which was size 30. It was trying to fit an x data of 50 to a size 30. Okay? Now you should be able to continue. What about you guys? Illegal target for annotation. What have you done? Well, before you reach this line, it already gave you an error here.
Yes, sir.
So I need to stop there.
Okay, put this line there and then cut paste.
Cut paste. So did it fit till here? That's perfect. Is that fine? Or which line was?
Only this line.
No, doesn't it say there's an error in the first line? From so, okay. Some of you might be getting an error due to y, and some of it is because you have been running a long line of code, and previously y was used as a variable somewhere. So let's just do y is equal to fx, so that y becomes f of x, and then that should operate from there onwards. Okay, well, can we just do line by line and see if it control x. Okay, that line works. Now save the second line. So we've got an error here. MLP regressor spelling सही है. MLP regressor, it's not a ML regressor. Good, she's got a good fit. MLP is an initial expected. Okay. So there's an error here. Once there's an error there, आगे बढ़ने का कोई फायदा नहीं है. Okay, so let's try to fix this error. Model is MLP regressor hidden underscore layer is equal to 3 times learning rate init. So what is it saying? Init got an unexpected keyword argument, hidden layer sizes. Hidden. Okay, now I have got an array in the next line at least, because we didn't define y here. So let's define y to be f of x. Okay, now see what's happening. What about you guys? Have you fitted? Good. So this is a, has everyone got it fitted? Somebody has a smile. काम कर रहा है. Let's just see the last girl. क्या चल रहा है आपका? Oh boy. आपकी फिटिंग कुछ ज़्यादा नासाज हो रही है. No, that's fine. The plot statement can't be wrong. Okay, fine. Let me check. Just do Control Z. So you fit it. Y underscore C Daisy. Try again. Yes. Okay. So a number of you should have got a fairly decent fit. So of course that won't be the last of the story, right? So we used a 3-layer, so it has 3 layers of hidden layers, each with 256 nodes. The question we have to ask, do we need that many? And there's a reason I'm making you ask this question. So quite often when we do AI programming, because we think there is a GPU, we just go for the highest size, deeper network, काम कर देगा, let it just work on it. So let's try to play with this. Will 2-layer work? Right now I have 3 layers of 256 node, right? Let's see if 2 layers work. If 128 nodes work, if 64 nodes work. So here we have got hidden layer size to be 3 times 256. Let's try with a 2 times 256. May not be very good. See कितना बुरा हो रहा है. And after that we will take a 5-minute breather, okay? Because this will be the last we will be dealing with short data and we'll now go for a big database. So थोड़ा सांस लेना जरूरी है. So 2 layers of 64 क्या कर रहा है? So you have to run the whole thing again. Define your model to be 2 layer of 256, do fit again, and then predict again and plot again. Or you can always write this as a method of its own. कुछ फिट हो रहा है? Of course taper आएगा, okay? But is it too bad? It's not too bad, right? Compare, what's the size you have gone for? 2 layers of 2. Let's do 2 layer of 64. हाँ. क्या हो रहा है आपका? Okay, कुछ error आया. Let's go 2 layer of 64. I don't think actually आप जब ये रन कर रहे हैं ना तो ये पिछला वाला ही ले रहा है. So let's run it again here. Okay. And copy and put all of them in one. Okay. इन सबको एक में डालिए. And then we will do. Yeah. So copy and paste there. So क्या हो रहा है? अच्छा नहीं लग रहा है. कुछ तो गड़बड़ किया आपने. और आप क्या कर रहे हैं? आपने हैंग कर दिया अपने मशीन को. इतने पर ही. So we have got the first hang. Well done. हमारे यहाँ when I started programming, हम लोग मेन फ्रेम कंप्यूटर पर प्रोग्राम करते थे. Right? It was desktops नहीं थे. And this was a single machine with 30 terminals. So everyone has a terminal of each person. And because it was a single processor machine, it was a time shared machine. Okay. So अगर आप लैब में बैठे हो और एग्जाम चल रही है, आपका रिजल्ट नहीं आ रहा है, which often happens in computer science. Oh my God, this is recorded, right? So the trick to do कि मेरा नहीं आए मैं किसी का नहीं आने दूँ. So what you have to do is you have to do a pointer fault in C. और पुरानी मशीन थी, the moment it gives a pointer fault, it used to dump the memory. So memory fault core dumped हो गया तो अगले आधे घंटे तक सारे के सब कंप्यूटर hanged रहेंगे. Not only you have hanged everyone else at the same time. So unfortunately that's no more a problem. Can you hang your neighbor's computer? इतना भी नहीं कर सकते तुम लोग. Okay. Good. So we have one hang and we are going to get more hangs very soon because we are going to increase the size of our neural network. और किसी के पास GPUs हैं उनके हार्डवेयर में? One person has GPU. So let's see. And you know what's the best situation will happen? His will hang the first. Good. So we'll take a 5-minute breather. When we come back, now we will download not a live data, but we'll download a data sequence from the web page of the author of the book whose I'm following, so that in case when I'm not here, you can still follow the sequence. So most of these codes and exercises are in the Helpshake book. So we'll download a sequence of a sequence of time series data of some prominent shares. We will take Apple, Amazon, Intel, Microsoft, and something like S&P 500 index, gold prices, USD, Euro prices. So we'll download these over a time sequence, see how we can visualize them, see if there is any correlation between various factors. I mean, one we could see is कि जब Google का बढ़ा तो Amazon का भी बढ़ा क्या? And then see, can we use our time series approximation to model that real data? ये तो simple था, right? Okay, थोड़ी curve is see what auto approximation works there. Okay? 5-minute break लेते हैं. So I've given you a web page link. We are going to download that CSV data onto your computer and save it somewhere. Okay, wherever you save, because that's the path we have to give to the read command for CSV file. Okay, it's a fairly straightforward link. It's tr_icon_eod_data. And wherever you save it in your Jupyter or Q2, go to that particular directory. So go by CD so that we can see that directory. Okay. So can you get a CSV file from the link? अगर नहीं मिले तो I can give it all to all of you in a USB stick. And once you have that file, we will do the next thing is we will do the classic import. It may not be a bad idea. So you will see a file like this. Okay. And it's a fairly large file compared to what we were working on till now. It's not very large, but it has got 2000 rows. Okay. सबको मिल गया? With me? So it is a abridged data file. It's not the full data file, but it contains few things of interest. For example, it gives you the Apple stock, Microsoft stocks, Intel, Amazon, Goldman Sachs as a representative of bank, the SP 500 indices, the volatility index, euro US dollar pricing, and some other indices. We will see what these indexes are in a point of time. So first thing first, there are, as you can see, there are gaps in the data, which is fine. No data is continuous. We will and sometime we have the okay. So save the data file somewhere, and let's read the data file in Python. So once again, I have given you the code for doing this work. Something till here should be fairly straightforward. And once we have read the file, all we will do is we'll plot the file. Okay? So the structure is of reading CSV file here is very simple. We give the file name, we say where the index column is, and we say that if you see a dates, think of it as a date. Okay, that's it. So from tomorrow onwards, we will do chocolate pricing. I haven't brought my chocolate prices today. But people who do the first thing, we will put a 1 rupee chocolate as a prize. Can you get a chocolate for 1 rupee now, or you don't? What we used to come for 5 paise before. See, in Europe, I often do a alcohol price, but I guess that might get me killed here. So errors which are typical happen here, you will get an error immediately after the open file name error, and that would be because you're not in the directory on which you have saved the file. So I have saved my file in the data directory while I'm sitting one directory above that. Other than that, the only other errors which you should hope to have here are any spelling mistakes or syntax errors which you might have done. And when I'm plotting, all I'm saying is give a larger size figure, because smaller size figures will get compressed into one, and then I saying that do subplots. CSV not found? What's error? Now you see, if you're shaking your head horizontally, I can't figure out, because in South India shaking your heads horizontally means yes, and in North India it means no, and Odisha sits somewhere in between. So it's very difficult to figure out कि आप लोग North Indian हो कि South Indian हो. I'm not doing my walk for this thing. It's just inputting a file and plotting it. We're not doing any work right now. I would love how my YouTube video of this lecture will be me just sitting there waiting for you guys to finish your work. And I can write राउरकेला गए आधे घंटे बैठे रहे बच्चे कुछ काम कर रहे थे. Let me walk and see what are you guys up to. इतना टाइम नहीं लगना चाहिए इसको टाइप करने में. बाबू you're not getting the directory. कहाँ सेव किया फाइल को? डेस्कटॉप डाउनलोड्स में सेव किया है, राइट? इसको कहीं भी रखो. लेट्स क्रिएट let's call it data folder. Okay, इसलिए नहीं हम चाह रहे हैं क्योंकि I don't want to disturb your other collection of stellar movies. कहाँ है ये? कहाँ है? Jupiter. So अगर आपको नहीं पता है कि हम कहाँ पर हैं तो let's do print working directory. Sorry, pwd. This tells me where I am. Right now I want to go to my downloads folder, and now that code will work because downloads में हमने data रखा है. Okay, good. Same problem. आप तो गाड़ी चला रहे हो. Save it in anywhere. Okay, those of you who can't figure out where they are in their Jupyter notebook, just type pwd. It will print your working directory. हो गया, right? Plot भी हो गया. So you can see 12 graphs. Good. Colorful graphs. So हम लोग जब पेपर्स पब्लिश करना शुरू किए थे, अभी भी IEEE में कलरफुल ग्राफ्स के लिए ज़्यादा पैसा देना पड़ता है हम लोग को. So it's $175 per page कलरफुल कलर के लिए. क्या हो रहा है आपके अपने यहाँ? Can I? Okay. It's unable to find that path. Problem यहाँ है ना? File name is equal to R क्यों रखा? आप यहीं पर रीड कर रही है इसको. So let's check हम कहाँ पर हैं आप desktop.gyan.py dot इसमें है ना where is your okay I will tell you a trick let's see कि हम किस हमारा working directory क्या है why don't we move ourselves there oh pwd is not defined ये क्या हुआ भाई no such file or directory see ये डबल स्लैश क्यों मार रहा है सब में that's where an issue lies somehow it thinks it's a double slash why can't we just go to that directory cd करने से क्या होता है that's where I am right let me go to desktop GIAN okay and now directly उस फाइल को ही ले लेंगे okay नहीं we just make our file name to be just that हम उसी फाइल पर हैं ओके सो जनता क्या हो रहा है डू वी हैव 12 फिगर्स आप लोग का भी है मैं आपको परेशान कर रहा हूँ नहीं अब जब कैमरा फिट करते हो मैं मूव कर जाता हूँ 12 आ रहे हैं गुड मैं भी मैक में हूँ कहाँ पर फाइल है डाउनलोड्स में ना शो मी योर जुपिटर शो मी योर पाइथन कोड सो मैं सो आप सो वन सिंपल इज गिव द फुल पाथ आप फुल पाथ दे सकते हैं यहाँ पर The other alternative is कि full path मत दीजिए okay let's go to that directory so मैं just एक ये आप compiler based रख रहे हैं क्या are you online not on the computer oh brilliant okay then we can't save it on the machine we have to save this file on the online location नहीं उसका पाथ ही नहीं होगा सो डू यू हैव ए कमांड प्रॉम्प्ट सो उसका पाथ जनरली आपके मशीन में होगा स्लैश सिस्टम डू यू हैव कमांड प्रॉम्प्ट हियर no not that आप इसका पाथ खोज रहे हैं ना so generally Mac में if I can get your terminal where is your terminal command console और terminal xterm है क्या आप में xterm भी नहीं है okay terminal है good so हम लोग black screen पर प्रोग्राम करने वाले लोग हैं so you are this is in downloads right and this is where you have got your the long file. So if you do print working directory, that's your path, slash user slash Vishal Kumar Singh slash downloads, right? अगली बार login name छोटा रखना, विशाल कुमार सिंह टाइप करने में, right? एक तो हमारे इंडियंस के नाम ऐसे ही लंबे होते हैं, उसके बाद हम लोग पूरा नाम रखने लगे तो 64-bit encryption भी कहीं नहीं जाएगा इंडिया. Okay, so most of you should have got a waveform like this. Okay, so as you can see, we have got shares, we have got indices, we have got gold prices, we have got euro things, and you don't need to do this, but these are the instruments which we are plotting here. Okay, now you can certainly do very simple things like this. You can find the mean, you can find the average of what's going on, you can aggregate things. So this is over dates. The other thing which we would like to know is not really what was the absolute stock price. That's of little interest to financial decision making. But what was the change which happened, right? If a share goes up or down, that's more interesting. And the change you can do by diff function, but again absolute changes of little value is the relative change. अगर 1 रुपया था उसका दाम और 1 रुपया 10 पैसे हुआ, compared to 100 रुपया था और 100 रुपया 10 पैसे हुआ. So 100 रुपये में 10 पैसा is no profit, but 1 रुपये में 10 पैसा is 10% profit, right? So what we're interested in is the percentage change which has happened in the share. So what I would like you guys to do is to plot the percentage change. So let's look at these three. So dot head will give you what the data looks like, what the first 5 rows of the data looks like, and the second one will plot the percentage change as it has happened. So let's look at the percentage change and plot this thing. At the same time, sometimes we are more interested in the logarithmic change, because okay, let's do the percentage change and then you will know why actual percentage change is of little interest and logarithmic value is of more, gives us more important information here. Can you access your file? कर रहा है आपका? तो स्ट्रेंज बात है कि had you had a Windows machine, I am hopeless in Windows. मुझे कुछ नहीं आता और अब मैं भूल चुका हूँ Windows को अब. But Linux machine any day, that's my bread and butter. So first task we are doing is we have got a time series data. We will now try to visualize it. And visualization में हमें ये दिखाना है कहाँ profit आ रहा है, कहाँ loss आ रहा है, कब हम stocks को खरीदें और कब हम stocks को बेचें. So जब आपने percentage difference plot किया, what does it look like? Which is the most beneficial right now? कि सबसे ज़्यादा change किस में हुआ है? Dot V, which is the volatility index. Okay. Amongst the shares, which is the one which has changed the most? And we're talking about 2010 to 2020 data. So 10 साल के data हम लोग देख रहे हैं, right? So let's look at the first 5, which are Apple, Microsoft, Intel, Amazon, and Goldman Sachs. Now we're looking at percentage change here. PCT is It does not tell us whether they gained or they lost. I mean, most of them have changed pretty, but let's go back to the absolute number. So you said the VIX has changed the most in percentage terms, right? Its absolute value is around 30. If it changes 10 in 30, that's 30% change. Okay. And this is why you see there's a big change there. And hence sometimes rather than the absolute change, it's better to have, because that figure would be looking much big compared to the other ones, right? So it's sometimes interesting to have a log change. You see how it has a, can you also do the log change plot? I've given you the the code for log here. So हर फाइनेंशियल इंजीनियरिंग कोर्स के पहले एक स्टैट्यूटरी वार्निंग दी जाती है, डू नॉट यूज द नॉलेज गेन्ड इन दिस कोर्स फॉर एनी इन्वेस्टमेंट डिसीजन, प्लीज अप्लाई योर ओन ब्रेन, इफ समथिंग हैपन्स टू योर लॉस योर प्रोफेसर और द इंस्टीट्यूट इज नॉट रिस्पॉन्सिबल. हम देना भूल गए थे. Okay, so they told that's the VIX index. What do you guys think? Which has changed the most? VIX. And when we do a log change, I'll come down and have a look, because I can't see what you guys are working. क्या हो रहा है बाबू? Okay. Plot भी कर दो इसको. जब आपने कैलकुलेट किया ये तो प्लॉट कर दो. सो सिर्फ उतना ही करोगे जितना मैं स्क्रीन पर दे रहा हूँ. You still stuck? Okay, let's see. My data dot CSV or just my data? So let's do the simple fashion. Okay. And मैंने क्या दिया था? Hold a second. Let's run this. And that's the name of the file. There's no CSV extension in your file. Are you sure? No, let's check. Because this is calling it's an XLS worksheet. So how does it know it's an XLS worksheet if it does not have an extension? A Windows file, right? It already has a CSV extension. It's not showing you the extension because आपने hide कर put an CSV there and let's see. Then run the file open command and see if you can open the file for read. Can you? So once you have seen how much these numbers are changing with period of time, we also have a problem. This data is a daily data. Often daily data is not of much value to us, particularly when we have got a daily data over a 10-year time span. We would like to take snippets of this data. It is of value to us, but it has got quite a lot of day-to-day fluctuation. And second, it makes any computation quite challenging because the data set has become very big. And right now we only have 5 shares and 4 indices here. I mean, imagine if we have 500 shares or 5,000 shares, it will be quite challenging for our computers to work with. So one thing which we often do in machine learning is we downsample the data. We don't look at all the data points, but fix data points at certain point of time, right? So here we could downsample it on a weekly data or as a monthly data. And once again, we have a very simple method already provided there of data resample. And if you plot the resample data, you should look something like this. Okay. So try resampling. So this is the cumulative sum of the resampling data as to how the cumulative sum goes up. So try resampling one of them while I try to solve the problem of this girl, and then I will come back and see. Any luck? What are you doing? Let's see. And you went back to your full naming, is it? Permission denied. That is interesting. Why do you have the permission denied error on your own? That's not the file name, is it? It's the location. Where's the file name? क्या नाम दिया आपने? इसको रन कर रहे थे हम लोग. You know what? Are these two different codes? Okay. Let us see. Or मेरा the my trick of going to that particular directory did not work. Why doesn't it take PWD? Oh, we are in that directory now. Okay. So we should be able to read directly from here. But हमने खोला नहीं है ना इस फाइल को. It's equal to कैसे खोलते हैं, remember? ये ना. Such file. What is that? Fine, fine. Ah, okay. ना देखते हैं क्या होता है. It does not like printing working directory. PWD काम तो किया था यहाँ पर, and we are in that directory anyway. Is this file here in GIAN.py folder? CSV, okay. So why are you not liking us? No, there's no reason for it not to work. मैंने क्या गलती की है इस लाइन में? Guys, can you show me your file open command? Just I want to check if I have done a silly mistake here. There. I've opened file name. Double quotes. Single quotes. Thank you. Still does not like it. File name is, you gave a full path name to this, right? is nothing mistaken here. Corrupt file नहीं है ना? No, the file is perfect. So what have we? What difference will that do? Why does it give double quotes in? Then it says permission denied. You have, hold a second, पहले से error आ रहा है क्या? Let's not do multiple types here. This is your CD. We are already in that folder there. ये किसी और का गड़बड़ था क्या? You tried the full bit, right? So let me try to delete all of these and fresh start fresh. अब delete करेंगे सबको. So that's not the data, right? It's now called file name should be in double quotes. Let's see if that works. Okay, so if that is, then our data line should work, should it? D.read.cs. Why is the tab not working? Okay. Index underscore column. Underscore data is equal to true. Let us see. It's going to be Paris, it's parse data. Sorry. Okay. Guys, can I have a look at your code again? The read code, just with the one which worked last line. There, just go down. Read CSV got a, so you have got parse underscore dates, it's not data. You're parsing dates here. File not found error. Interesting. But that file exists according to you, right? And it is in that location. Guys, give me a minute. I will come down. CMD. No. Windows, oh, okay. That's the name of your file. Okay. Do you need to see the rest of the code, or you'll be able to follow it? Okay. Good. So we can downsample the data and we can see the data at different orientations. Let's now try to see what's happening to a particular share and see if we can do a better visualization in form of its min max value, where exactly it is falling down, and if we, when should we decide to sell or buy the same. So we use something called rolling statistics or financial indicators, and these indicators could be statistical numbers like standard deviation, mean, max or min, but we are looking at rolling over a particular window. So rather than looking at the mean, so 10 साल के mean से क्या फायदा है हमें? Not much, right? What we need to see is कि अगर हम 20 clock point या 10 clock points का mean ले रहे हैं, how is this mean shifting over a period of time, and how is the max shifting over a period of time? Okay. So one thing which we could do is we could go and find the rolling mean and this function here. So we have taken the Amazon share here, or you can take the Apple, or you can take any one of them. So I just take one of these and then create a series out of the original data frame. So just I'm taking one data series now rather than the whole series. Okay. And once we have done that, I create a particular window size, and that is within in the yeah. No, you will see it very soon. Okay. So what we would like to know is, right now I have got a curve pattern just like this. What is happening to the moving average of my curve? So I'm trying to bring the moving average concept. So we have got an average, but you don't take an average of throughout the history. That's not going to tell us much. Average of last 6 months is going to tell me, and what has happened to the 6 months average over a period of time, or a monthly average of my data over a period of time. Okay. So what we are now going to do is going to find this window based minimum value, maximum value, and we can find other statistical parameter as well. Let's just deal with the minimum value over a particular window, maximum value over a particular window, and the average value in that particular window, and then see how does that changes over a period of time. Okay. I will show what I'm expecting to see. We are expecting to see something like this. This is what is happening to my curve form. This is the range in which it is moving over a period of time. Again, small absolute data values are of less fundamental value to my investment decision, right? Each data point doesn't help me. So let's do the rolling statistics for any one of the. So pick your share. Right now we are saying Amazon, pick whichever one you want to do and do a rolling statistics of, let's take these three, min, max and mean, and then plot them for the last 200 data points. So not plotting throughout of the all data points, we're just plotting the last 200 data points. So don't worry about typing the standard deviation. This is just for me to see the data. How did the data look like? And drop NA, because a number of these will be not NA terms, where there was no data. So we're going to drop all the NA terms by doing this. Okay. And let's just plot the last 200 of these and see how they look like. और आई कैन स्लोली सी आप सबों के चेहरे पर थकान आ रही है कोडिंग करते करते. आप लोग अगर इंडस्ट्री में जाएंगे तो इससे ज़्यादा लंबा टाइम वो लोग खटाते हैं. Don't worry, we'll do just 2 more exercises and then we'll call it a day. Okay? You want me to stop in half an hour, 20 minutes, 10 minutes?
Yeah, we can extend. So because from 5:20 we have another class here.
Yeah.
So before that maybe after 9 hours.
Oh, is it already 5? Okay. Then we'll do this one as the last one. Okay guys, why don't we take a picture of this? And then 2 more things which I would advise you to take picture of. So we expect to see something like this, because I have been warned I'll be kicked out of this room very soon. So we expect to see a rolling statistics of this order. See if you can also plot the actual data on top of this. So this is min max mode. See if you can also plot the actual data on top of this and see how it works. And tomorrow we will start this looking at single moving average and see if we can utilize single moving average for trading decisions. Okay dokie. Good. We'll stop now and we'll revisit it tomorrow. Bye for now.